Your book is about ice, among other things. But ice is where you kind of start off the book. And you talk about first going to the Arctic in 1970 on the research ship Hudson. How did that happen, and why did you become interested in ice in the first place, and the Arctic in particular?
Well, I was always interested in the ocean, and the first oceanographic voyage that I had the opportunity to take part in was when I was young, and it was a Canadian ship going around North and South America, the Hudson. It was the first and only time that the Americas have been circumnavigated, and it took a year to do it, and that meant we started off going down to the Antarctic, and then on the way back we came through the Northwest Passage. So I had plenty of time to study ice, and so got very interested in that, as opposed to some of the warm waters in between, and made that my field of research. And in those days very few people were working on ice, so there were a lot of unsolved problems, and it was a very interesting field. Now ice has become much more important, mainly because it's disappearing, so a large fraction of the world's environmental scientists are now interested in ice.
So ice and the shrinking ice sheets in Greenland and the Arctic and Antarctica, we hear about that a lot in the news, but this whole habit of observing ice patterns goes back quite a ways to whalers, of all people. Someone named William Scoresby, you mentioned in the book, in the 18th and 19th century. Tell us a little bit about that. Why were whalers so important?
Before whaling developed in the Antarctic, which is when they really wiped whales out because they could catch the fast swimming whales, it was important in the Arctic. In fact, whaling in the Arctic produced the oil that was used to light towns in New England. We sort of think about hydrocarbons being used wastefully. The ultimate must be using whale oil to light a street. And that was all whales caught in Greenland and Baffin Bay. And the whalers, in doing that, made very valuable observations about the ice, how much of it there was. For instance, there's a big protrusion of ice on the east coast of Greenland that whalers were the first ones to notice, and that recently disappeared, which has had a big climatic effect. So they were very valuable in telling us where the ice limits were in the 19th century, and it's helped to show us how much the ice has retreated over the last few years relative to those days.
Excellent. Julie, 3 words for you. Change, human-induced climate change, but give us some context. Tell us a little bit about the Milankovitch cycles and these longer periods of climatic shift that happen naturally over many hundreds of thousands or millions of years.
Well, they're well understood, so perhaps I'd rather say something about what's happening to sea ice now in the last few decades, because when I first started working in the Arctic, the ice that we could see was very much very heavy ice mostly. That's if you can see the picture, the multi-year ice, which is really thick, like mountains of ice, occupying the whole of the Arctic Ocean between North America and the Asia. And so the psychological feeling you got was that the worlds of the Northern Hemisphere are joined together at the top, because the ice extends right across the Arctic to join Canada to Russia, and we're all one. But in recent years, the ice has been retreating faster in the summer, but also in the winter as well, so that instead of a continuous cover across the Arctic, you now have you have open seas in summer months, which has changed everything. It's changed the nature of the ocean itself, and has produced a lot of feedback effects. And the first part of my book is actually concerned with this, because when you see the sea ice retreating and thinner ice and less of it every year, the temptation is to say, well, this is a curiosity. It's obviously global warming has caused it, but it's just a curiosity, like the disappearance of glaciers from Kilimanjaro. But in fact, what we're finding is that the loss of ice from the Arctic is having much bigger effects elsewhere in the climate system. So we can't just think of Arctic sea ice retreat by itself. it's affecting the whole climate system to a greater extent than just the loss of ice. So the open water in the summer is now giving us accelerated warming of the world, and it's causing warmer air to spread over the Greenland ice sheet, and that's making Greenland melt faster, which is giving us an increase in the rate of sea level rise globally. So that's noticeable here in the Gulf of Mexico, everywhere in fact in the world. Sea level is rising at an accelerated rate, and that's the extra contribution is mainly from the melting of the Greenland ice sheet. That's due to the sea ice retreating in the Arctic. And another effect is that we're getting a possibility of higher amounts of methane being released from the Arctic Ocean surface, because there's a lot of methane held in sediments under the continental shelves of the Arctic, and as the seabed sediments thaw out, they're still frozen after the last ice age, that allows the methane below to get out, and we're now seeing big plumes of methane coming up into the atmosphere, and again causing an acceleration of global warming. And I guess the final, or the not final, but as two more serious big effects which affects people here are the fact that as the sea ice retreats, we're getting warmer. The Arctic is warming faster than the rest of the world, so the temperature difference between the Arctic and the lower latitudes is going down, and that's reducing the strength of the jet stream. That's the rapid wind or air mass that separates the Arctic air from the tropical air, and you experience it when you fly from US to Europe. It helps you on your way. And that jet stream has slowed down because these winds have decreased in strength because the temperature difference goes down, and the jet stream now is producing big lobes. Instead of being straight, it's in big vertical lobes, and each lobe brings polar air down into some low latitude region like the Midwest, and warmer air, it takes it up towards higher latitudes where it shouldn't be, like the northeast. So you're finding alternating regions right around the world in mid-latitudes where it's either exceptionally hot or exceptionally cold, and these extremes of weather have been seen for about the past 8 years, coinciding with the retreat of sea ice. And they span the latitudes where we're getting most crop production, and so they're having a very disruptive effect on crops and causing global food prices to rise, which is really serious for third world countries. So we're finding another effect on the global food production, and that's the life of people. And the final effect, which is really important for around here with hurricanes, is the fact that off northeast Greenland, this place I mentioned, which was first spotted by whalers, is a location where ice used to grow in the winter and cause the surface water to sink. The ice rejects salt into the ocean, and that helped to produce a slow circulation of water in the Atlantic, not the same as the Gulf Stream, but in the same direction. And that circulation, called the thermohaline circulation, has slowed down because that ice is not being produced anymore, and the result is there's less warm water from the Gulf and the Caribbean being carried to northwest Europe, and that means, because there's just as much heat going into the world, that means the hot water stays down here, and the surface water temperature down in the Gulf and in the Caribbean is warming up faster because the water's not being transported as efficiently up to Europe. So Europe's cooling down, or it's not cooling down, but it's warming slowly, but the Gulf is warming faster. And this hot water is what intensifies hurricanes. The warmer the water at the surface, the more intense the hurricane. So we're getting hurricane intensification because of the slowing down of this current, which takes water away to northwest Europe. So I guess the point of all those is that sea ice retreat in the Arctic doesn't just affect the Arctic, it affects the whole planet, and some parts of the planet are affected much worse than the Arctic itself. And one of the places affected badly is round here because of hurricanes getting more intense and sea level rise affecting low altitude regions, which is a lot of the Gulf Coast, Florida and Louisiana.
Great. So Peter, in your book, you talk about this notion of tipping points. Do you feel that we've reached a tipping point with respect to climate change?
Yes, I think we have. A tipping point is where if you stop poking something with a stick, it goes back to sleep. I mean, if you don't have a tipping point and you poke a lion with a stick, and then you stop poking it, it goes back to sleep and everything's okay. If you reach the tipping point, you poke the lion and it comes and eats you, and so it's an irreversible process in science. And the question is, have we stressed the climate or the planet so much with all the extra carbon dioxide we've added that if we manage to find a way to take it away, then we'll go back to where we were before? And I think we still can. I think we haven't reached that tipping point that, say, Mars or Venus reached, where they lost all their water and became completely lifeless. But we can go back, but we have to, first of all, stop producing carbon dioxide into the atmosphere, and then we have to, more important I think, is we have to find a way to take a lot of it out of the atmosphere. We've got a lot too much in the atmosphere now. What we've put in already is enough to give us unacceptable global warming. It's not a question of reducing our emissions. We've got to not only reduce our emissions, but we've got to get rid of the stuff that's there already. So we need a big research effort on methods for taking carbon dioxide out of the atmosphere directly. And it's just technology, but it needs a lot of money to develop it. But once we've developed it, we've solved global warming. So I think we needn't feel totally gloomy about global warming, because we can find a way to get that carbon dioxide out of the atmosphere if we spend enough on research to do it.